All right, let's see. I have that it is 31 past the hour. So I'm going to go ahead and get started with the introductions and stuff. And I'm sure more people will still be coming in. So my name is Fran, and I am the Director of Physics at Vernier Software and Technology. And today I'll be presenting to you on projectile motion using Vernier Video Analysis, which is something that's pretty awesome in my opinion. Assisting me today is Tom. Tom is going to be monitoring the chat and the question answer. He will answer questions by texting, but he will also be able to interrupt me and say, hey, Fran, there's this great question that you should answer for everybody. I do not know what that was.
B21 is back up.
It's just like at school, isn't it, Fran?
Just like it. Yeah. I'm sure that you are all familiar with exactly that kind of thing happening. So yes, we do have announcements here as well. Also here today in the webinar is Angie. Angie will be putting some links in the chat for you. She will also be the one who gives you the link to the recording when this is all over and your certificate. So all that will be provided after the webinar is complete. So again, welcome, and let's go ahead and get started. So I'm going to start with the basics, and I am going to zip real fast through a whole bunch of stuff. So don't feel like you have to follow along on your own copy of Vernier Video Analysis as we're doing this, because you could very well fall behind. There will be the recording, so you'll be able to refer back to that. And there's just, this will be quick. But again, we do want to answer your questions, so do put those in the question and answer. Vernier Video Analysis is a progressive web app. So that means that it works on a browser. So we suggest Chrome, Firefox, Safari, the latest version. If you find out that you're having trouble with Vernier Video Analysis, oftentimes that's because your browser actually needs to be updated. I have run into this more than once. It will work on all your devices, including tablets, phones, Chromebooks, as well as your Windows and Mac computers. Back in the day, we used to get a big CRT TV screen and we'd roll it into the classroom on the giant cart. And then we put a big transparency over. We'd have hooked up to a VHS video player and try to step through frame by frame and use a wet erase marker and make these little dots on the screen and try to make a scale, the ruler based on something that you could see in the video. And yeah, we thought that was pretty cool, but then software came along. And it is so much better now. And now you can do it on Chromebooks. So you can do it, because it's on any device, you can do this anywhere, including while not connected to the internet, as long as you have connected to the internet to get it set up. So just like you can open your browser when you're not on the internet, it says, oh, you're not connected to the internet. If you then pull up the Vernier Video Analysis app, it should still show up. And as long as you logged in within the past, a couple weeks, and it should come up and be perfectly usable. We've got experiments available online, including the one that we're doing today. And it's also in the shared Google folder that Angie just put in the chat. So you'll be able to access that. We also have a book called Vernier Video Analysis, Motion in Sports, which has, I think, 12 activities in it. And we're also working on some additional activities now to be released next year as well. So lots of resources. We think that this is good for students at all levels. You can't do projectiles with a motion detector or a photo gate, two of the things that we sell a lot of, are motion detectors and photo gates, but it just doesn't really work for projectiles really well because of, how the motion goes. So here you go, you use video analysis, and then students can immediately analyze that projectile data, think critically about it, it's a great resource in that way. And what I really love is you can overlay vectors onto the motion. So I'm going to show all of that. I'm going to show my screen now. So let me pull that up. All righty, so there it is. The link is videoanalysis.app, and I'm going to put a link in the chat for you. Let's see. Yes, so that link will get you there, or if you're already on this page on your browser, you can just put into the license key there, which I'm going to also put that in. This is a temporary key. It's going to expire on August 9th, but this gives you a chance to play around with the video analysis app and get a chance to try it out. So let me go ahead and submit this license key. That says success, gets me in, and it brings up all this stuff here. So I could start a new experiment by importing a video from my phone or computer. That's going to be any video that you have on local storage. It's hard if you're connected to a Google Drive. I believe you can also get it from Google Drive. It depends on how your file system is set up. You can also open a video analysis file that you have already created to revisit it. There's a link to the user manual, which is slightly out of date. That's one of my tasks before September, is to get that updated. And then we have a whole bunch of sample videos in here. So the one we're going to look at is the basketball shot, and they all have this little cloud because they live on the internet to begin with. So I'm going to have to download that. And then it gives me the play button, and then I'm going to import that. Oh, sorry, I didn't actually hit send for the license code. Sorry. So here you get the Vernier Video Analysis app screen, and here we have our video. You can simply play through to see what that looks like. You'll notice at the bottom of the screen, it says Vernier Video Analysis access expires in 12 days. That's because, as I said, this is a temporary link that will expire August 9th, and you can play with it until that time. And the screen comes up with all this stuff on it. Well, the first thing that we are interested in doing is getting this basketball trajectory into our data. This button puts us back to the beginning, but I really don't want to start analysis at the beginning, because in the first few frames, the person has their hands still touching the ball. So the ball is not in free fall yet. And usually we think about projectile motion as when the only force acting on the ball is going to be the force of gravity. So I'm going to step forward a few frames until the ball has just left the person's hand. And then I'm going to use this little triangle. And this little triangle actually just means that that's where the ball is, that's where the frame where the video analysis is always going to go back to, instead of going all the way back to the beginning. And you can do that at the end too. You can trim it at the end. This doesn't actually trim the video at all. It just trims what part you're going to be looking at. And students sometimes will have a very long video and only a very short amount of the video has the motion they're interested in. It's a good idea to trim that video in some sort of video editing software before you put it into video analysis. But if they don't, this is still a great way for them to be able to focus on just the part of the video that they're interested in. There are some other controls on here that we might be interested in. For example, this gear gives you advanced video options and lets you change your frame rate for advancing frames. So with every point that you place, the movie automatically advances 1 frame by default, but you can change that to 2, 5, 10, 20, or 50. That can be really useful if you're doing high-speed video. And then also important for high-speed video is having the video frame rate be something you can override, because the whole point of high-speed video is like they play it back at 30 frames per second and then everything looks really slow. You get this nice slow motion. But you don't want the timestamps of each frame to be every 1/30th of a second. You want them to be the actual timestamps for the frame rate. So you need to adjust the frame rate to say, oh, well, I actually filmed this at 120 frames per second. So that's what you're going to have to put in there. I'm not going to change any of that now. What I am going to do is start by adding my points in, which you can do by putting this target, this crosshairs over your object and just click and it makes a dot. And then, as I said, it moves forward 1 frame. I can do that again and click and it'll make a dot and it moves forward 1 frame. Now I'm choosing the center of the basketball. You want to be consistent in where you mark the projectile. So either if you start with the center, always mark the center. If you start with the bottom edge, always mark the bottom edge. If you start with the top edge, always mark the top edge. But it's going to be a little bit tedious getting through this. It says I've got 62 frames of this to get through on this. I'm on frame 9 of 62. I'm going to set up auto tracking on this, which is especially nice for things where you've got just a ton of frames, especially for things that were filmed in high-speed video, or for things that are moving really slowly at the beginning. So I'm going to adjust it so that my target only includes the basketball, and then click on Start Auto Tracking. And there it goes, and it collects the data. So I see a question. Are these capabilities still available in Logger Pro? So auto tracking was never in Logger Pro. So that's a thing that works on Video Analysis app and also in our Video Physics app, which is a paid app on the Apple App Store. So that can only be used on iPads and iPhones. It can't be used on a Chromebook or on an Android or anything. So yeah, so this is an added functionality that is not in Logger Pro. So there are all of my points. At this point, the ball bounces, and that's where the auto tracking, because it's suddenly moving in an unexpected direction, it actually loses the target. And so I could reset the target. I'm not going to for this demonstration. I'm just going to leave that as the total number of points that I've collected. So as you collect the points, they automatically show up on the graph and in the data table. And you'll notice that the units here are in px. Px stands for pixels. So right now, it's only getting the pixel locations on the screen. So I'd like to get that into something that's more related to the measurements we normally use. And so I'm going to go to this icon over here on the left, which is System. And I'm going to move this thing here to set the scale. And I've got a meter stick down here. The meter stick's actually kind of hard to see. So I'm going to zoom in. I have a trackpad on this laptop. And the trackpad, I'm just using you put 2 fingers on the trackpad and move them apart to do the zoom thing. And then I can go the other way to get them back. There's these 2, I don't know who made this video. There's like a yellow sticky notes on the ends. So it's hard to tell where the ends of the meter stick actually are. I think I'm getting it. All right, and that's 1 meter. If it were a longer or shorter thing, then I could change that here. Sometimes you're taking a video of something that's up close. You want to use something, some smaller amount than a meter. I could, if I knew how tall the person was, I could have used the person's height as the scale, but that's what I've got for this meter stick. Zoom back out by pinching my fingers together on the trackpad. And then the other thing I want to do is put in an origin. The origin by default just sticks over here kind of in the lower left corner. I'm going to go back again to the beginning of the video and make my origin at the center of the basketball when I started tracking the motion. And notice how that immediately changed the graph. It changed the axes of the graph so that the first point of the horizontal and vertical position is at 0, 0. And it's also now having units of meters. So now this is something that we can, say, oh yes, this looks like real stuff here. So I want to go ahead and do some analysis on this. And right now, my graph is kind of small here in the corner. There are 2 ways that I can get that graph bigger. One way is by making everything else smaller using these little handles. The other way is to go up here to the top right to the view options menu and get rid of the video and get rid of the table. So I'm just looking at the graph. And I could look at 1 graph, or I could look at 2 graphs. Now, by default, the program just shows both X and Y, and it by default for the top graph, it's going to just choose position versus time, and for the bottom graph, it's going to choose velocity versus time. And you can change those very easily by clicking on the vertical axis label. If any of you have used our graphical analysis software, it's pretty much the exact same user interface, so that should be familiar. So say I want to look at maybe just the X position graph on here because I want to get the horizontal velocity. And then here, I want to look at the horizontal velocity graph down here. So now I've got horizontal position versus time and horizontal velocity versus time. Just as a reminder, I'm going to bring the video back here. When you set the origin, you're also setting which direction is X and Y, and by default, positive X is to the right and positive Y is up. But these arrows indicate that you can actually tilt these around. You can make, like if you have a falling object, you might just want to make X down, right? Because that just, that's how you solve the problem when you just have a numerical, word problem to solve. But for this case, we'll keep our X is horizontal and our Y is vertical. And go back to I wanted to do just the graph here, just the graph, and I want to go back to 2 graphs. So there you go. So I, of course, can get the horizontal velocity 2 ways, and that is by doing the slope of the position graph, and move that up so you can see it. I've got a slope of 2.241. And then I could also look at the horizontal velocity, which is supposed to be a constant. I don't know what's going on here. It's supposed to be a constant. Oh, well, take a look at the scale here. The scale is between 2.1 and 2.7 here. So what I'm going to do, 2 things. First, I'm going to edit the graph options and make the y-axis range down here. I'm going to do automatic scaling that will always show 0. So that puts this up here and it says, oh, look, it is all going to be pretty flat, pretty constant here. I'm going to go ahead and get the statistics for that one. And you'll see that the average is 2.3. Here, my slope was 2.241. I think that's pretty good. That's a pretty good match. So now, of course, we want to look at the y direction because we're very interested in the Y direction as being different from the X direction. The whole point of this is to show that you can separate the analysis into two different components here. I'm going to get rid of the curve fit and the statistics. Notice that I've got these things on the screen. You can actually look at any given point and get some information about it. But for now, I might want to say, all right, this is a parabola up here. I'm going to apply a quadratic curve fit. And here I'm going to put a linear curve fit. Oops, linear curve fit. And get that as well. And we can see from our information here that my slope for my linear curve fit on the velocity versus time graph is negative 9.4. We would have liked that to have been negative 9.8. This is a great opportunity to ask your students, okay, so why? Why is it not negative 9.8? What's going on here? And I'm sure you can think of a number of reasons. And then here we have the quadratic fit up at the top, and that A component, or that A, what do you call the numbers? It's at the front of, it's in front of a variable. Coefficient, that's it. The A coefficient is negative 4.6, which is very close to being half of negative 9.4. It's actually, you know, if we round that to negative 4.7, it's even closer. So very nice. And there's our basic analysis. A couple things I want to show you on here. First of all, you can do a custom curve fit. So for my custom fit, maybe instead of having a quadratic fit in the form of ax squared plus bx plus c, I actually want to have a custom fit. And a reason that I might have a custom fit is that I just think that my C component should be 0 because it started at position 0 because I defined it that way. And so I might just call this new quadratic, but it lets you do these custom fits in here, which is, you know, nice if you have a need for that. So there's apply. I'm going to get rid of quadratic, and my new quadratic is very slightly different from the original. And notice that it doesn't have that C because there's no variable. And it's pretty helpful when you're trying to try a custom fit. It'll tell you, oh, your syntax is not good. And that's one of the updates I need to do on the user manual. So I'm working on it. All right. So I did want to show a couple other things on the video, which are really cool. So I'm just going to go back to just showing the video here. One of those things is objects. So it's possible that you might have two things. And so you can go ahead and add a new object. You can also change the color of the object if you want. So what that does, if I go back to, let's see, first I want to add points. So I've got this first dot is now pink. If I play through, it shows them pink dots instead of blue dots. That playthrough was pretty quick. I might want to replay that so it's slower. So I can replay this anywhere between like 1/10 of the speed or up to like 10 times the speed. So I can just replay that. And if I also were to include the graph on it, it would show that coming up on the graph as well. So this is a really nice way to show this. Get rid of the curve fit on there because it takes up a lot of space. Get rid of this on there and go back to the beginning and show that replay where it's both coming up on the graph of Y position versus time and also showing up in the video. Pretty cool. So the other thing that is really cool about this that I mentioned at the beginning is the ability to overlay vectors. So there's 3 vector possibilities. You could do position vectors. That's just going to be an arrow to each point from the place that you chose at an origin. Or you can do velocity, or you can do acceleration. So this shows that they're not being shown. Putting on this gives you both components and the resultant. And this gives just the resultant, and this just gives just the components. And you can scale these, so you can make them longer or shorter as needed. And then the other thing you can do is change how often they're shown, which is, I think, even more useful, because this is where you can say, all right, I really don't need one every single dot. Every other dot, maybe a little bit less than every other dot. And then you can display that, and you can say, oh, look at that horizontal vector. Look how constant that is. Not perfectly constant, as we know, but it's pretty darn constant. Look at these vertical vectors, and look how they change from going up to going down. And then you can also add in the acceleration vectors. The acceleration vectors are almost always not as good, especially when you do auto tracking. If you're doing tracking by hand and being very precise with it, you can get much better resultant vectors than these for acceleration. So a little bit off there. I like to stick with showing the velocity ones, because I think those are really awesome. So that is pretty much all the stuff that I wanted to show you. Our half hour is nearly up. I just want to remind you of a couple things. First, the user manual is available also right up here in the top right-hand corner under that 3-dot menu to distribute this app to your students. Once you have it, you can just copy that link and give that link directly to your students. If any of you have students right now, you can actually do this with this free 12-day trial until August 9th. You can have students try that out until then. And you can get a free trial by going to copy and paste into the chat, and this time actually remember to send it and sharing the link to the app. Yes, I can do that as well. I'm going to copy that link and put that link in the chat, and there you go. I'm going to stop sharing my screen right now, and we've got about time for maybe 1.5 questions. Tom, have you seen any questions come up that I didn't get to?
No, I think we've answered them. Well, we didn't talk about the cost of the app, of the service.
Right. So the cost of the app actually depends on how many students you're going to be using it with. So there is one price for a smaller number of students and another price for a larger number of students. It is an annual license fee. So once you buy it, it lasts until the end of June the following year. So if you bought it now, it would last until June 30th of 2022. Similarly, if you bought it in December of this year, it would last until June 30th of 2022. So that's not going to be a great deal. But if you buy it in January of 2022, it's going to last you till June 30th of 2023. So if you buy in January, it's a good deal. But then after you've done it once, then it's always going to be just, the one calendar year. It'll be just 1 year. Your only chance for a good deal is the first time you buy it, if you buy it in January and February. But you can find it by going to our website. Let me just stick the link.
While you're doing that, I'll just note that the price does vary depending on whether you're a high school or a K-12 school or college. And it depends a bit on the number of students using it. So if you're less than 100, it's one price. If it's more than 100 students, it's another price. So the best way to look at the price is to go to that link that Fran put in the chat. Yep. And check that out there.
Yep. And the link for the free trial is on that same page. If you scroll down on that page, you get to a bunch of tabs that go across. One of those tabs is free trial, and that's where you sign up for the free trial. So that's actually the same page. Down, just got to scroll down to and click on free trial. All right, our time is up. Thank you so much to everyone who attended. Again, Angie is going to send you out a link to the recording and also a certificate. And if you have any questions, you can email us at physics@vernier.com. You can call us. Our phone number is on our website. If you click on the chat with us button on our website, you can get us on chat. That's going to be during business hours for the Pacific coast. So, don't try to get to us at 7 a.m. Eastern time, because we will not be available then. I'm sorry. Bye-bye, everybody. Have a great rest of your day.